Welcome, everyone. Today, we are diving into a critical component of your enterprise AI strategy, determining how to effectively use generative AI and knowledge sources within Microsoft Copilot Studio. Let's start with the basics. What exactly is generative AI within the context of Copilot Studio? Traditionally, building a conversational agent meant manually writing out every single conversation path and anticipating every possible user question. Generative AI completely changes that paradigm. With the Generative Answers capability, your agent can dynamically surface information without needing those manually authored topics. It actively interprets natural language queries, performs multi-source retrieval, and synthesizes answers directly from your enterprise data. For solution architects, this means shifting your design focus away from scripting dialogue and towards securely connecting your agent to the right knowledge assets. Looking at this diagram, you can clearly see the modern AI workflow. A user asks a question, which hits our Copilot Studio agent. Instead of looking for a hard-coded script, the agent leverages its generative AI engine. It actively searches through your enterprise knowledge, retrieves the relevant facts, and synthesizes a dynamic, highly accurate response on the fly. It is a seamless, data-driven process. Why should an enterprise prioritize generative knowledge in their AI strategy? The biggest reason is speed to value. By eliminating the need to manually author a topic for every potential question, you can deploy a highly functional agent in a fraction of the time. Furthermore, this approach dramatically expands the scope of what your agent can handle. When users ask obscure or highly specific questions, the agent doesn't fail, it searches your data. Most importantly, this process relies on grounding, which means the AI's responses are strictly tethered to your trusted, domain-specific organizational data, minimizing the risk of inaccurate information. It can also serve as an intelligent fallback when a user's intent doesn't match your structured workflows. This mind map highlights the core value pillars of generative knowledge. On the top right, we have speed to deploy, driven by reduced manual scripting. On the bottom right, we achieve high accuracy through data grounding, which actively reduces hallucinations. And finally, on the left, we gain massive coverage, providing broad Q&A capabilities and serving as an intelligent fallback when standard topics miss the mark. To properly design your strategy, you must understand how the agent orchestrates tasks. Copilot Studio offers two primary modes, Classic and Generative. Classic orchestration is rule-based. The agent relies on predefined trigger phrases to route a user to a specific topic. Generative orchestration, however, acts as an intelligent, autonomous dispatcher. It uses large language models to analyze the user's intent and dynamically selects the best topics, tools, or knowledge sources based entirely on their descriptions. This mode is incredibly powerful because it can handle complex, multi-intent queries fluidly, even automatically generating clarifying questions to gather missing inputs from the user on the fly. Here we compare the two orchestration modes side by side. When user input arrives, classic orchestration looks for a strict match with trigger phrases to launch a fixed topic. In contrast, generative orchestration analyzes the intent, reviews the descriptions of all available tools and knowledge sources, and dynamically routes the request to the most appropriate asset. It's a shift from rigid pathways to dynamic reasoning. Now, let's explore where this knowledge actually comes from. A robust AI strategy requires mapping the right data sources. For external information, you can use public websites, which Copilot Studio indexes via Bing search to instantly cover FAQs and public policies. For internal, secure documents, SharePoint and OneDrive integration is paramount, allowing agents to retrieve enterprise files while strictly honoring user permissions. When you have structured, relational business data, Microsoft Dataverse is the ideal source. Finally, for third-party systems like Salesforce or ServiceNow, you can use enterprise connectors to provide real-time knowledge retrieval without ever having to replicate or move your underlying data. This graph illustrates the hub-and-spoke model of agent knowledge. The Copilot Studio agent sits at the center, reaching out to diverse sources. It can pull from public websites, reach into SharePoint for unstructured files, query Dataverse for structured tabular data, or use enterprise connectors to securely access external APIs. This unified reach is what makes the agent so versatile. Let's deep dive into how Copilot Studio handles unstructured data, like your PDFs and Word documents. When you point your agent to a SharePoint site or upload a file, that data is securely ingested into Microsoft Dataverse. But it doesn't just sit there. To make it usable for AI, the system automatically chunks the files into smaller, logical pieces and converts them into vector embeddings. This process, called semantic indexing, allows the agent to match the actual meaning of a user's query to the concepts inside the documents, rather than just doing a basic keyword search. Furthermore, background synchronization jobs ensure that as your SharePoint files are updated or deleted, your agent's knowledge remains fresh and accurate. This flowchart demystifies the ingestion pipeline. Starting on the left, a SharePoint document is ingested into Dataverse. It is then broken down during the chunking phase and mathematically mapped into vector embeddings in a database. When a user query comes in, it bypasses the raw file and performs a semantic match directly against those embeddings, resulting in a lightning-fast, highly relevant AI response. For enterprise scenarios requiring massive scale or highly complex reasoning, we must look at advanced grounding techniques. If your dataset is exceptionally large or complex, integrating Azure AI Search provides unparalleled vector search capabilities and high-precision semantic ranking. For heavily utilizing Microsoft 365 data, enabling tenant graph grounding with semantic search uses cutting-edge retrieval to give the agent massive context with incredible accuracy. Alternatively, you can use Azure OpenAI on your data to connect Copilot Studio to your own private Azure OpenAI deployments, allowing for deep, specialized reasoning over custom indexes. Crucially, these advanced methods ensure that proper citations and URLs are maintained, so users can verify the source of the AI's answers. Let's trace a complex query in this sequence diagram. The user submits a prompt to the agent. The agent forwards a vector search request to Azure AI Search, which quickly returns the most relevant document chunks. The agent then packages those chunks with the user's context and sends them to Azure OpenAI. Azure OpenAI synthesizes a coherent, grounded answer, which the agent delivers back to the user complete with clickable citations. A critical part of your design strategy is establishing architectural constraints and security rules. Security is paramount. By enforcing Microsoft Entra ID authentication, Copilot Studio ensures that an agent will only ever surface knowledge source content that the specific user is explicitly authorized to view. You also need to design within platform limits, such as the maximum of 500 knowledge objects per agent. To protect your brand, robust content moderation filters intercept harmful or malicious content at both the input and output stages, and you can adjust this sensitivity. Finally, for highly regulated environments, you can toggle the Allow Ungrounded Responses setting to off, forcing the agent to answer strictly from your provided knowledge sources and never from the model's general internet training. This flowchart illustrates the robust security gauntlet. First, user input hits a content moderation filter. If malicious, it's blocked instantly. If safe, it hits the Enter ID check. The system excludes data the user cannot access and retrieves only allowed knowledge. Finally, based on your settings, the system checks if ungrounded responses are allowed, ensuring the final output is either strictly tied to your data or enhanced with general knowledge based on your compliance needs. To wrap up our strategy, let's look at the decision framework for selecting the right knowledge architecture. Your choice depends heavily on data complexity and precision requirements. If your data is highly structured and relational, you should leverage Microsoft Dataverse tables as your knowledge source. If you are dealing with semi-structured data that demands high-precision semantic ranking at a massive scale, Azure AI Search is your target. For the vast majority of unstructured enterprise documents like PDFs and Word file, SharePoint and OneDrive integrations are perfect. Finally, if you just need to handle low complexity, general Q&A, pointing the agent to your public websites is the fastest, most effective route. By aligning data type to the right tool, you ensure optimal agent performance. This decision tree is your ultimate architectural guide. Start by analyzing data complexity. If it's structured, route to Dataverse. If it isn't, ask if it requires massive scale and high-end semantic precision. If yes, Azure AI Search is the answer. If no, determine if the data is internal or external. Internal documents belong in SharePoint or OneDrive, while external FAQs are best handled by public website indexing. This guarantees the right tool for the job.